Hello everybody. Today in our exciting mathing video, we are going to do section 11.2 in our algebra book. Section 11.2, I know we skipped one, but you'll be glad because there's graphing, so it's totally fine, I'm sure. So 11.2, page 719. Here we go. We're simplifying radicals. Now, because we have such awesome, super cool calculators, some of this can be done on your calculator. However, because I want to make sure, and I'm supposed to make sure, that you know how to do it without your calculator, sometimes I will make you show your work so I can see that you know how to break down a radical without using your fancy calculator, okay? So let's look at page 719, example number 1. Our job is to simplify the square root of 32. Well, if you look on your calculator and you do square root of 32, it will do this for you, okay? It'll simplify it for you and give you the correct answer. But I need you to be able to show me how you got that, because on some of your homework, I'm gonna have to see your work, okay? So this is how you do it. It's kind of like a fraction. It's kind of like a factor tree is what they're called. They're kind of like that. So what I'm gonna do is I'm gonna break down 32 into what two numbers multiplied make 32. Okay, so there's a lot of different ones you can choose. No matter what you choose, you will still get the correct answer. Okay, it doesn't matter. If somebody wants to choose 4 and 8 and somebody else wants to choose 16 and 2, it's totally fine. We'll all get the same answer. Okay, so I'm going to choose 16 and 2 just because 2 times 16 is 32, right? Now we try and break down both of these numbers. Can I break 2 down at all? Except for 2 times 1, which doesn't count. We just can't, so we leave it at 2. But I can actually square root 16. The square root of 16 is 4. So I can actually go ahead and square root this number, and when I do, it's now outside because I square rooted it. Just like if I had 64 and I square rooted it, my answer would be 8, right? The square root would be gone. Okay, it's the same concept. Once I square root that 16, it's gone. And I have a 4 now, okay? And I couldn't do anything with the 2, so it stays under the square root sign. It's as simplified as it can get. There's nothing else I can do with that without getting to a decimal, which is not what we're doing today, okay? So this would be my simplified version, which should be what you got on your calculator. Let's look at B. In B, we involve some letters, but it's totally fine. I'll show you how to do those too. So the square root of 9x squared, I think cubed. Okay, so let me write it out longhand. That's really a 9 times an x and an x and an x, right? Okay, I'm going to show you two different ways real quick. Either one is fine. You'll get the same answer. Just do which one makes sense to you. For me, first I'll show you the longer way. 9 can be broken down to a 3 times 3, right? I should rewrite that for you. So we have a 9 times an x times an x times an x, 3 of them. And 9 can be broken down into a 3 times 3, but I still have my x's, okay? All right, so now we can do this 2 ways. This one, I could just go ahead and say square root of 9. What's the square root of 9? The square root of 9 is 3, so I took care of doing that and I brought it out, okay? This is really 2 x's, which I really could write as x squared, right? And the square, if I square root a square, it cancels out, right? And I bring it out. I only have 1 left in there. I can't do anything with just one of them, so it stays. So this would be 3x root x, simplified. Now this way, I did it this way as well. If I don't want to square root a 9, I can do this. This is the rule. If you have 2 of the same number, you can cross them out and bring that number outside. It's the same thing as square rooting the 9. If I break down the 9, I have 2 3s, I cross them out and bring 1 3 outside. It's the same process, just do the one that makes sense to you. So now if I have 2 x's, I can cross them out and bring it outside. And look, I ended up with the same exact thing. I have a 3x on the outside and an x on the inside. Do it either way, okay? Let's try our next example. I have to keep my videos short because they won't let me post ones that are longer than a certain time because I don't have like a professional account or something. All right, so let's do example 2. We have root 6 times root 6. Example 2, page 720. Root 6 times root 6. So I can put everything that's under a square root sign in the square root together. Okay? So if I have 2 of one number, I can cross them out and bring it outside, right? Or you can do this. 6 times 6 is 36. What's the square root of 36? Square root of 36 is 6. If I had done it this way, cross them out and bring it outside, there's nothing left in my square root sign, so I'm just left with a 6. Okay? So this is a super useful thing to remember throughout the rest of your mathing career. A square root of 6 times a square root of the same number, so a square root times a square root of the same exact number, ends up being just whatever number that is inside. This is why 6 times 6 is 36, and when I square root it, I get 6. So if you have the square root of 2 times the square root of 2, the answer is just 2. Okay? It only works if your numbers are the same though. Like what if I have square root of 100 times the square root of 100? That answer is 100. Because square root of 100 is 10. 10 times 10 is 100. Okay? So if the square root of a number times itself, basically, their answer is just that number plain, no square root. All right? Let's look at example 2b. Square root of 3x, and then I have times a 4 square root x. So what I like to do is I like to put everything that's on the outside first, and then I put, since we're multiplying, I put everything that's in a square root symbol together under 1. I just combine them and put them all under 1. It makes it a little easier to keep everything straight. Okay, so can I simplify a 3? I can't multiply, I can't divide it by anything but 3 and 1, so it has to stay. But I have 2 x's, and what's the rule? If I have 2 of something, I can cross them out and bring it outside. Now, all I have left inside is my 3, and I can't do anything with that, so that's simplified. We're done. Okay, let's try example 2, letter C. Square root of 7x y squared times 3 square root x. Okay, so I take what I have on the outside, I put it first. I put all my things that I have on the inside together. You see what I did there? I had a square, but I just wrote 2 of them. I just wrote it out longhand. Okay, can I reduce a 7 to anything but a 7 and a 1? Nope, so we're just gonna leave it, stays, no problem. Now, remember, if I have 2 of something, I can cross them out and bring it outside. So I have 2 x's, so I'm gonna cross those guys out and bring it out here. I have 2 y's, perfect, I'm gonna cross those out and bring it out here. So outside I have a 3x and y, and on inside I only have a 7 left. And it's now simplified, okay? Okay, hopefully you're doing okay with that. It's kind of like when we're crossing out things across the dividing line. It's just a matter of getting rid of stuff and moving it around. We're just simplifying. Okay, let's look at example number 3. If I have a fraction that's in a square root sign, again, our super awesome calculators will do that for us as long as we put it in parentheses so it knows it's square rooting the entire fraction. But I'm going to have you show me some of it so I know you know how to do it like without your calculator. So when you have a fraction that's being square rooted, you square root the 13 and the 100. You just apply a square root to the top and the bottom. And then we do them separately. Let's see, can I simplify 13? I think it's just a 13 and a 1, right? So we have to just leave that the way it is. Can I square root 100? Yes, the square root of 100 is 10. And so I've now simplified. That's all I can do because I can't divide here because there's nothing. You can't like reduce this like a normal fraction. Okay, so square root of 13 over 10. Let's try B. 3b. Square root of 7 over x squared. Okay, remember, first thing we do is we give each of them their own square root. Okay, all right, and now can I square root of 7 at all? Can I simplify that to anything besides a 7 and a 1? Nope, it stays. What does a square root and a square cancel each other out? It's the same thing as this, right? Remember, when there's 2 of them, I can cross them out and bring it outside. A square cancels a square root. We're left with just an x on that bottom there, okay? And there's nothing for us to reduce, so that's as simple as it can get. Sometimes when you're done simplifying, you'll end up with a square root sign on the bottom of your fraction, okay? And that's bad. So we have to get rid of it. So that's example number 4. There, I can't simplify square root of 7. I can't simplify just a regular 5, but I'm not allowed to have a square root on the bottom of a fraction. So to get rid of it, I multiply itself by itself on the top and the bottom, because remember, we have to be fair. Whatever happens to the top, we have to happen to the bottom, or it's no longer the same fraction. So we multiply whatever the square root is, we multiply by itself, because this is a 1, right? So we can multiply by a 1 and it's okay. So now we multiply across the top, 5 times the square root of 7. Now, we just learned this in example number 2. If I have a square root of 7 times itself, what is my actual answer? I hope some of you are saying it. It's 7. This is why, remember, 7 times 7 is 49. When I square root it, I get 7. So that's that little trick I showed you that I told you we'd use a lot. Square root of 7 times the square root of 7 is just the number 7. The last thing we have to check is, can I reduce 5 over 7? Nope, can't reduce 5 over 7, so I'm done there with that. Okay, let's look at B. Square root of 2 over the square root of 3b. Okay, I can't reduce any of those, but I'm not allowed to have this square root on the bottom, right? So what do? Okay, I multiply by itself. I heard somebody say it that time. But be fair, do it to the top and the bottom. Now, we multiply across the top. Remember, we can put everything inside if we want. 2 and a 3 and a b, right? We'll deal with that here in a second. I'm just going step by step. 3b, square root 3b times square root of 3b is just 3b, which is awesome because now we got rid of our square root, but we still need to deal with that top thing a little bit, okay? So, can I simplify a 2 at all? No. A 3? No, and I can't bring them outside because there's only one of each of them. So I just go ahead and multiply those and leave that as a 6b over a 3b. And that would be the simplified version, okay? All right. Very quickly, I need to go over example number 5. I know I'm going kind of fast. I apologize for that. Example number 5 is just learning to combine like terms when we're dealing with square roots, okay? All right, and then we have a -9 square root 10, okay? So in this equation, this term right here is considered a like term with this one because they both have the same square root number. This one has a square root of 10 and so does this one. So you have 4 square root 10s and -9 square root 10s. Those are considered like terms, just like if it was a 4x and a -9x. So when you have like terms, you can combine them. So 4 minus 9 is -5 of those, and we still have this. I can't combine these because this one's a 10 and this one's a 13, not the same. I can't break this down at all, so I'm done with this. Okay, so like terms means if they have the same number under the square root, you can combine them and say how many total you have. Sometimes they're not quite ready to combine yet, and that's example 5, letter B. 5 root 3 plus root 48. These are not like terms, correct? They don't have the same number, but I can simplify this one, okay? So let's take care of simplifying that over here. I got a 48 as a 6 times 8. 6 would be a 2 times a 3, and 8 would be a 2 times a 4, okay? So if I have 2 2's, I can cross them out and bring it outside. I could square root this 4. What's the square root of 4? 2. I can bring that outside. And then I just have a 3. Is there anything I can do with a 3? I don't think so. So this ends up being, we multiply these, that ends up being 4, and that ends up being 3. So instead of the square root of 48, I can replace that with 4 root 3. Great news. These are now like terms. I can combine them. 5 plus 4 is a total of 9. Okay? And my time is almost done. I'm going to have to stop. Good luck. Call me if you have any questions. See ya. Bye.